Okay.
Which one's which?
Oh, like which number system is which?
Yeah.
Let's kind of go through piece by piece. Like I did yesterday, we're going to skip from binary. We're going to actually start out with octal numbers, just because it makes more sense with octal. Binary is almost too easy to start with, because if you start with them, then it's tougher to transition into the other ones. So we're going to look at page 511 here in your packet. Now remember, in the decimal number system, which is base 10, our place values are powers of 10. You know, 10 to the 0, 10 to the 1, 10 to the 2, and so on. You know, 10 to the 0 is just 1, 10 to the 1 is 10, 10 to the squared is 100, 10 to the third is 1,000, 10 to the fourth is 10,000, 10 to the fifth is 100,000. Those are our place values that we're used to. You know, 10 to the negative 1 is 1/10, 10 to the negative 2 is 1/100th, and so on. And when we put a digit in those place values, when we put a number in there, like 357, that is saying 3 times 10 squared, or 3 times 100, and 5 times 10, and 7 times 1. So when we switch over to another numbering system, what changes is the place values. Now I should mention, of course, being base 10, the largest digit we can use is 9, 1 less than our base. Because if we hit 10, that puts us to the next place value. So if we look at octal numbers, base 8. Instead of 10 is the base of our numbering systems, it's 8 is the base. So 8 to the power of 0, 8 to the power of 1, 8 to the power of 2, 8 to the power of 3, 8 to the power of 4, and 8 to the power of 5. So 8 to the power of 0 is still 1. 8 to the power of 1 is just 8. 8 squared is 64. 8 to the third is 512. 8 to the fourth power is 4,096. 8 to the fifth power is 768. I missed that a little bit, didn't I? So 32,768. So when I put numbers in there, like 3752, oops, 37526, we'll say. Notice base 8, the largest digit I can use is going to be 7. Can't have anything larger than 7, because 8 would be into the next place value. So what does that mean? Well, that means 3 times 4,096. Just like up here, that 3 was in the hundreds place. It was 3 times 100. Well, what is 3 times 4,096? 12,288. Okay, that looks better. And then 7 is in the 512's place. What's 7 times 512? Perfect. The 5 is in the 64 place. That's 5 times 64, which is 320. 2 is in the 8th place. That's 2 times 8. 16, and 6 is in the 1's place. That's 6 times 1, which is just 6. So if we add these up, that'll tell us this is in base 8. This is going to be back in base 10. So at 12, 18, 24, 10, 18, 21, 4, 9, 12, 6, and 16. So 16,214 is what we've got there. This is base 10. That little 10 there indicates that's base 10. That is equivalent to 37526 in base 8. Notice I didn't pronounce that 37,526 because it's not thousands and hundreds anymore. So the first thing we need to be able to do is, like on the top of page 511 there, convert each octal number into decimal numbers. So what you need is this table right here, telling you what each digit is. So for the first one, 12 in octal. Well, this is pretty simple. This is the 1's digit and this is the 8's digit, right? So it's 1 times 8 and 2 times 1. 1 times 8 is 8, 2 times 1 is 2, that adds up to 10. So 1, 2, I shouldn't have said 12. 1, 2 in base 8 is equal to 10 in base 10. Does that make sense? No? So basically what we're looking at is we're saying we're putting slots in here. Whatever goes in this slot is times 1, just like in our standard numbers. Whatever goes in this slot is times 8. Not times 10 anymore, it's times 8. Whatever goes in this slot is times 64. We're going up, multiplying by 8 every time, powers of 8. Whatever goes in this slot is times 512. So if I give you 3526. This is in base 8. This is a base 8 number, or octal number. We just go through digit by digit and we call its place value. So this is 3, but it's times 5. Each one of those is worth 512. So that's 3 times 512 is 1536. The 5 is in the 64 place, so each of those is worth 64. So that's 5 times 64, which is 320. The 2 is in the 8's place, so each of those is worth 8. So that's 2 times 8 is 16. And then 6 is in the 1's place, so that's still just 6 times 1, or 6. We add those up to get what that value is in base 10. That's 18, 4, 6, 7, 5 and 3 is 8, and 1. So 1,878 base 10 is equivalent to 3526 in base 8 in octal. So I'm going to have you do is with, looks like they don't go past 4 digits, so we're just going to do 1s, 8s, 64s, and 512s. They're listed as our place values here. I want you to work through 1 through 8 there. Probably start, let's do 5 through 8. Convert those into base 10 for me quick in your notes. Well, let's take a look. Yep, this is 25.3. Number 5 is 324. $212 is what I get. Yep. So let's take a peek. So number 5 was 212. Number 6, 635. Okay. 413, you think? Well, let's give it a shot. So 6 times 64 is what, 384? 3 times 8 is 24, and 5, so that is, I'm getting 309, or 409. Did I do something wrong? That should be 96. What is 384? That is 384. Oh, yep, I'm off. So I got 635. Yep, that is 413 is what I'm getting. You're right. I just added wrong. Let's see. Number 7 is 777. 7777, I should say. 4095. Okay. Well, 7 times 512 is what? 3584. 7 times 60. Yep. 7 times 64 is 448. 7 times 8, of course, is 56. And 7 times 1 is 7. So what do we have there? 25, create a 2, 19, 3995. 4,095. Did I miss? Oh, yes, I did. I missed a carry there. So 4,095. Wow. I'm just going to stop trying to do adding in my head today. 095. That looks better. And then 101. That one should be pretty simple. Or 1001. That's just 513. Any questions on those? Did you get any of them to work for you? Or? Okay. Yeah. So now let's go the other direction. If we have a decimal number and we want to go to octal. So we're going to have the place values up here again. 1, 8, 64, and 512. We can stop there. Remember, our largest digit is 7, so if something goes into it more than 7 times, we've got to go up to a larger place value. So let's say we're given 2,385. This is base 10, and we want to convert it to octal. So what we have to do is we have to see how many times we can take each place value. Can we get 512 out of that? Sure. 2385 is bigger than 512. So we're going to divide by 512. What do we get? It's like 4, right? So 512 comes out of there 4 times. 4 times 512 is 2,048, which is going to leave us with 337. Does that look right? So it's a division and remainder for each place value, for each digit. So the 512 went in. Now the next digit here would have been 4,096. That's too big. It wouldn't have come out, so we didn't use the 4,096, right? That's why we started with 512. So we took the 512 out of there 4 times, and there's 337 left. So now we try the 64. 64 goes into 337. Let's say 5 times. So that's 5. 5 times 64 is 320. So there's 17 left. Does 8 go into 17? Twice. So dividing by 8 is 2. There's 2 8s there. 2 times 8 is 16. Leaves us with only 1 left, and that has to be our 1s. So 4521 is the equivalent of 2385. base 10. Does that make sense? So you have to use those place values and do a division of remainder. Let's do one more. Let's do 937. So I've got 1, 8, 64, 512, 4096. Can I get a 4096 out of there? Nope, too big. Can I get a 512 out? Yes. Looks like it's only going to go once, right? We subtract the 512. We got 425. What are we going to do next? Divide by 64. Very good. So it goes in there, it looks like 6 times. 6 times 64 is 384. These are 41. Now we're going to divide by 8. 8 goes into 41 5 times. 5 times 8 is 40, so there's only one left. That's our ones. So 937 base 10 is 1651 base 8. What do you think?
It's a lot easier than I thought it would be.
Good. So what I want you to do is on page 511 again, I want you to do 13 through 16. Convert those from decimal to octal. Let's just take a peek at how you've done so far. So for like the 216 divided by 64 is going to be 3. I didn't use 512 because 512 was bigger than 216, so we can't take that out. So 3 times 64 is 192. 3 times 64?
I'm sorry, we're on number 13.
Let's do 212, not 216, so you're right. Thank you. So yep, that is 212. So we subtract and we get 20, right? So now then, I don't know, I'm way off today for some reason. Dividing by 8, 8 goes into 20 twice. 2 times 8 is 16, that's left with 4, so it's 4 1. So 324, 324. I'm going to show you a shortcut here now. For number 14, it's 481. Can we get 512 out of that? Nope, so we're going to go to 64. So we're going to divide it by 64. Is 7.5. So I'm going to put down the 7. Now I'm going to subtract the 7 and multiply back by the 64. I've got 33 left over. I'm going to take that divided by 8. That's 4. So I subtract the 4 and multiply back by the 8. I'm left with 1. So the 481 becomes 741 in octal. The 1100 would be easy to go from octal to decimal. Decimal to octal is not quite so simple. So we do have to do the 512 here. So I'm going to divide out the 512. It's going to give me 2 point whatever. So there's 2 there. I will subtract the 2 and multiply back the 512. So it's 76. So I take out the 64. That's 1. So I'm going to subtract off the 1 and multiply back by 64. 12. Now at this point, I can take 8 out of there once and there'll be 4 left over. So 2114. And then the 3030, same thing. 3030, I'm going to divide by 512. I get 5. Subtract the 5, multiply back by 512. 470, so now I'm going to divide out 64. Is 7. Subtract the 7, multiply back by 64. 22, of course, 8 goes in there twice with 6 left over. So 5726, base 8. Any questions on those? Okay. So now we're going to switch over to hexadecimal. So are we looking at page 515 now on the packet? Hexadecimal is base 16. Now the first obstacle we're going to see here page 515. In base 10, the largest digit we could have was a 9. In base 8, the largest digit we could have was a 7, always one less than the base. Well, in base 16, the largest digit we can have is 15. 16 minus 1 is 15. So we're going to have to figure out how we're going to express a 15, up to 15. Well, what they do is simply, up through 9 is just a 9. 1 through 9 is 1 through 9. 10 is expressed with the letter A. 11 is B. 12 is C. 13 is D. 14 is E. And 15 is F. So now our place values this is the ones place again. This is 16 to the power of 1, which is just 16. 16 squared is 256. 16 to the third is 4,096. And then we keep going from there. But we're going to stop there because we're not going to use anything larger than that. So if I have a number like B9. To convert to decimal, or standard decimal notation, it's going to be 7 times what? It's in 256 place. That's 16 squared, so it's 7 times 256. Okay. What is 7 times 256? Perfect. 1792. B is in 11, so that's 11 times 16, which is 176. And of course, 9 times 1 is just 9. So what does that add up to? 1977, 1977. So we can make that conversion rather quickly from hexadecimal to decimal, just like doing the octal. So what I want you to do, let's have you do on page 515 there. I'm going to have you do problems. Well, let's have you do 6 through 10. On page 515. Have you try those quick, and we'll discuss those in just a second. So let's take a peek at what you have here. So number 6 is FF. Of course, F is 15. So the first one here is 15 times what? 16, so it's 240. And the second one is just 15 times 1, so that's just 15. So FF is 255. Number 7 is 1, 2, 3. Well, 1, 2, 3. The 1 is 256. That's just 256. The 2 is times 16, so that's 32. And then it's just 3 ones. So that is 291. Any questions on that one? You look like you had a problem with that one. Did you get to work? Number 8, 285. So the 2 is times 256. So that's 512. 8 is times 16. It's 124. And then 5 ones is going to give us what? 641. Any questions so far? So what'd you get for number 9? That sounds about right. So A is 10. That's in the 256 spot. So it's 2,560. Of course, 0 is a 0. B is 11 in the 1 spot. 2,571. And then finally we got BE7. What'd you guys get for this one? 3,047. Okay, so B is 11, right? Times 256, which is 2816.
That's what you got?
Yeah. 11 times 256. Okay. Yeah, I'm just doing the piece by piece. So B is 11 times 256. E is 14 times 16, which is at 224. And then the 7 is just 7 times 1. So what, 17 for 3,047. Perfect. Any questions on those? So now we're going to go the other direction, converting decimal into hexadecimal. So let's take a number like 872 base 10 and try to convert it. Got 1s, 16s, 256. That seems to be as high as they're going, is the 256. So again, 872, what's the largest digit we can take out of it? The 256, right? So we're going to divide by 256. It's going to give us 3. So you put the 3 in the 256. Now I'm going to subtract my 3 and multiply back by 256. So I've got 104. My next digit is 16. So I'll divide by 16. That's 6.5. So this is 6. Subtract the 6 and multiply back by 16. I'm left with 8. So 368 in hexadecimal. Not so bad. So let's say I have 249 base 10 and I want to convert it. Can I divide by 256? 256 is going to be bigger than the 249. So we can't divide by that. So we can divide, got to go down to the 16. So divide by 16 and we get 15, which is F. So we're going to subtract 15. Left with 0.5625, so times 16 again should give us 9. So 249 is F9 in hex. Does that make sense? So what I want you to do is I want you to do 22 through 25. Actually, let's do 22 through 26 on page 515 there. And we'll go over those in a minute. So let's look at number 22. We got 116. This is decimal. Now we're not going to get a 256 out of that. So we're going to see how many 16s we're going to get out of that. 116 divided by 16 is 7.25. So 7 16s. Subtract the 7. And multiply back by 16 leaves us with 4. So 116 base 10 is 74 base 16. For the sake of time, I'm going to skip up to 24. So 421 base 10. So again, I can't take a 512 out of that, so I'm going to divide by 16. Oops, what did I do wrong there? Oh yeah, we can get a 256, sorry, not a 512. We can get a 256 out of that, so yes. So 421 divided by 256 is going to be just 1. So that's 1. We subtract the 1, multiply back by 256. So we got 165 left. Now we'll divide by 16. It's going to be a 10. So 10 is what is a digit? 8. So we subtract the 10. And then multiply back by the 16 should give us 5/16. So 5. So 1A5. 421 base 10 is 1A5 base 16. How are those coming out for you? Those looking pretty good? I always do when I'm putting it up here just so it's clear which one's which. But in your paper, I mean, it's asking you to convert it to hexadecimal, so you know it's going to be hexadecimal, so you don't necessarily have to get it there. Binary is base 2. Now, if it's base 2, the largest digit, of course, is 1. And like we mentioned yesterday, the reason that this is so handy is for computers, 1 or 0, on or off. And that's how a computer thinks. So this is 2 to the power of 0, or the 1's place. 2 to the power of 1, or the 2's place. 2 squared, which would be 4. 2 to the third would be 8. 2 to the fourth would be 16. 2 to the fifth would be 32. 2 to the sixth would be 64. 2 to the seventh would be 128. If you're into computers at all, that series of numbers should look familiar. You have the 1K RAM, 2K, 4K. It's gone to 2 meg, 4 meg, 8 meg, 16 meg, and so on. They tend to run along those. Now they get in between them, but it used to be they stayed right on those. So anyway, the digits are going to work the same. It's actually quite a bit simpler because we only have zeros and ones. So if I want to convert this into a decimal number, we'll have 1 times 64, which is just 64. 0 times 32 I don't have to do. 1 times 16 is a 16. I'm not going to bother writing out the 1 times. 1 times 8 is 8. 1 times 4 is 4. 0 I don't have to worry about. 1 times 1 is 1. So we've got 10, 18, 22, 23, 8, 9. That's 93 is what we just wrote out there. One of the neat things about, well, it actually kind of works this way with all numbers, but it's just easier to look at with binary. What is the largest number I can write with 7 digits? Well, I look at the place value of the next digit. That's 128, right? So the largest value I could write with 7 digits would be 127. That would be 7 ones. It would be 127. Because this one would be 64. This would be 32. This would be 16, 8, 4, 2, and 1. If you add that all up, you're going to get 127. So converting from binary into standard is pretty simple. Converting from standard into binary is the same as we've been doing. It just often requires a lot larger numbers. So let's say I'm going to have something like 211, and I want to put it into binary. It's actually a lot simpler because it can either goes in there 0 times or 1 time, right? So 128 goes in there once. I subtract 128, and I'm left with 83. 64 goes in there once. Subtract 64, I'm left with 19. 32 does not go into 19. 16 goes into 19, I'm left with 3. 8 doesn't go into 3. 4 doesn't go into 3. 2 goes into 3, I'm left with 1. So there's my 1. It's really a quick conversion. So for your guys' homework for tomorrow, what I want you to do on page 503 to 504, I want you to work on 1 through 24. So you're converting from decimal, and actually we're not even going to bother with, we're going to do 9 through 24. Convert the binary numbers to decimal. Convert the decimal to binary. So actually, did I just have you doing the odds? Okay. Actually, I want you to do 9 through 42, so you can convert each direction. But we'll skip 1 through 8, because writing those in expanded form is something you guys know how to do. 9 through 42, you can do just the odds, it's fine. If you do that and you're still unsure, go back and do some of the evens if you want more practice with them. And then binary is way easier than the other two. But we show you octal and hexadecimal because it's a way of writing binary in a shortcut, which is what we'll look at tomorrow. Okay, I'll let you guys have your last minute to get started. Anybody have any questions? There's a lot of information in an hour. But
When are we going to be looking at our unit test?
Well, I had planned on it tomorrow, but hopefully we'll get it Thursday. So you guys can come in and do the unit test Thursday while Woods is... What I'll probably do is let you guys go in the other room so you have a quiet room.
This is